Hello and welcome. In this video we're going to look at how to make an emergency stop button for any 3D printer. This is not limited to printers either. It could be used for computers, CNC mills, anything with a standard IEC C14 connector, which is this one here. This will work with any of those devices because essentially we're just going to make an inline switch using a usual C14 power cord. Parts needed. You'll need one emergency stop button. I ordered this from China. Came pre-disassembled. Pretty cheap, but it'll work. Also comes with a little grommet. You'll need two compression glands. These are so you can get the cables into the box. These are slightly too large. I recommend 16mm ones. These are 20. You'll need two IEC leads. I made these for this example, but normally you can find them pre-made with any computer or printer or anything that you order online. And you'll need some connection blocks, either old school connection blocks or wagos, whichever one you prefer. So for this, tools needed, you'll need a drill. You need a step drill bit to drill the holes for the glands in the box. You'll need some wire cutters. You'll need some screwdrivers, and you'll need some fuses if you're using a 13 amp plug in the UK. This project involves mains electricity. If you do not know what you're doing, then don't attempt to repeat anything you see in this video. A note on currents. The stop button I'm using is rated for 10 amps at 600 volts, 660 volts. As this is a cheap Chinese part, it's probably dubious if it would actually work at 10 amps without melting. So I'm going to downrate it to 5 amps for a nice safety margin. I can do this by using a 5 amp fuse and a 13 amp plug. If the plugs where you live don't contain fuses, then you should use an emergency stop button rated for your socket circuit current. In Europe, that's likely to be 16 amps. In the Americas, it's likely to be 15 or 20 amps. Get your emergency stop button and dismantle it. This one came pre-dismantled. Decide where you want to fit your cable glands. I do not want to have mine on the side here. I want to have two on the top here. For my setup, you can see there is some plastic in the way, so I have to slightly modify my box. But alternatively, if you wanted, you could put them on the sides like that and save yourself this effort. So, now you need to decide where you want to drill your holes. I've decided there. These are 20mm on the outside, so I need to use my step drill bit to drill two 20mm holes. Once you've drilled one hole, you should do a test fit. That fits quite nicely. I'll just tidy up the edges with a knife. Not too bad. Now you just have to repeat this again. Once you have the glands in, then just use the retaining nuts to secure them in place. Mine don't fit very well, so I'm just going to trim off some of the sides of this. So now we have the glands fitted to the box. Yes, they're not straight, but they are fitted and they're tight. You can then reassemble the glands slightly by putting in the neoprene sealer ring and then loosely screwing on the outside. Once you've got your holes and your glands done, then grab your IC cords. So grab your cords, on one of them you want to cut off the plug and on the other the socket. Make sure they're not plugged in when you do this. Now these bare ends you want to feed into these here. And once you've got the bare ends, just let this slip down, it doesn't really matter. Use the wire cutters to strip off a generous amount of the outer insulation to expose the cables inside. This will expose the inner core cables wires. While I was doing this, I made a mistake and nipped this core here. That's not particularly safe, so I'm going to cut this off and redo it. But firstly I need to talk to you about colours. In Europe they are brown for live line, blue for neutral, and green-yellow for ground or earth. In the Americas they are black for hot or line, white for neutral, and green for ground or earth. So once you've stripped off the outer insulation, strip a small amount, about 7mm maybe, of insulation from the inner cables, revealing the copper strands. Once you've got the strands like this, just twist them together so they don't separate. Just pinch, twist and release like that. Do this to both ends of the cable. Pull the wires back to the beginning of the glands so they look like this. Then you want to tighten the glands. Now I've got quite a lot of play here because my glands are too big, so I'm going to use some PVC tape. But use correct size glands for the cable you're going to use. That's my advice. So here I've got the cables tightened nice and tight properly. I've got the live wires here and I've got the neutral and the earths here. These two just need to be connected together. These two are going to go to the switch. If you have any doubt, use this wiring diagram. So now I've got the earths and the neutrals just tucked away out there, and the lives remaining. For the switch, take the live wires and connect them up to the emergency stop switch. There are two sets of terminals, this set and this set. One of these sets of terminals will break the connection when the button is pushed, and one of them makes it. In this case, we're going to use the orange set. You may find it easier to dismantle the switch when doing this. Tuck the wire underneath the metal hasp and screw down tight. And do the same on the other side. Et voila. Reassemble the switch make sure it's nice and tight. Make sure all these connections are tight as they can possibly be. Loose connections will cause fires, and that's generally undesirable. Once the cables are all connected, tighten up the glands again. Make sure they firmly grip the cables, and just tighten it all up. You can hear it click. Then screw the box shut, and I'm gonna screw that on now. There we go. You can then sticky back plastic this to the surface, or you can even use the screw holes to screw it down, whatever you want really. The general usage of this button is that you push down to stop, and then if you want to restart, you twist it. If you wanted to reverse that, so you wanted to twist to stop, then you can just use the other set of contacts inside the switch. One other thing that I am doing now is I'm going to change the fuse inside here for a 5 amp fuse. This is actually a 3 amp fuse, so I'm going to leave that in there. But whatever you do, you must make sure the fuse rating is below the rating of the switch in your box. Again, if you live in Europe or if you live in America where they don't have fuses in plugs, then just make sure you get an emergency stop button that's rated for the current so that it can be delivered if there's a fault. So, plug to IC lead. You have an emergency stop button in the way. Hope you've enjoyed this little project and it's of interest to some of you. Please subscribe, and I'll see you on the next video.